Networking 101. This is a crash course. Okay? This is just skimming the surface of networking. Networking is an immense topic. Okay? It is hugely wide, hugely deep. There are so many avenues to go through within networking. There is no way we could talk about 1% of it over the course of this entire week. Okay? So, my biggest suggestion, don't try with your students. We have to teach our students some networking. Okay? Because it's all over the building controls industry. If you're doing building controls and you're not dealing with networks, I want to talk to you because I don't know how that's even possible, okay, without dealing with just standalone controllers that, anyway, you get the idea. Well, I have an opinion on pneumatics. I fix them really well. Uses a big hammer and a DDC controller. But anyway, the great thing about networking and controls, though, is 95% of the time or better, the bare minimum basics are what you're going to use. Okay? If you understand the basics, out in the field, most of the time, there are exceptions to this, our building control systems people aren't having to engineer an entire network. Most of the time, it's a short conversation with the IT people, conveying what you need from them, and hopefully getting it back. Sometimes, Bob is shaking his head, because sometimes it is a short conversation and sometimes it's painful. Okay? But, again, just a hint of it. And Bob, Lanny.
I agree with you. I think, even just some simple things like teaching the terminology.
Yes.
It will allow them to have a much more comfortable level of talking with the IT guys, whoever are in that building, and it puts those IT guys a little bit at ease, as long as you understand the terminology and systems, but don't have to necessarily be setting up the programming side.
You're absolutely right.
We only ask for a phone call, that's it. We do our own network, they stay away from it.
Well,
crying about 6 routers.
That's in your college.
Yeah.
And honestly, that is a very, very good approach.
You make your own, you can have them destroy the network any way you want.
Yep. And we are going to get into that. But out in the field, the modern building control system lives on the building's network. So having that interaction with IT is something that your students will probably have to do at some point. So giving them the vocabulary, as Lanny pointed out, to have that conversation. Because the truth is, people in IT are very much like us.
I think I say pneumatics.
I was going to say fixable with a big hammer. But people in IT really are very similar to us, especially on the networking end. They assume that anybody who's coming to talk to them has no frickin' clue what they are doing. Okay?
Or you're interfacing with somebody in IT that's really limited, it doesn't understand your need, and they only see in this box.
That is also
and
true.
Then you got to really smack them around until they understand what's going on.
So, if you can establish that first conversation and get them to realize that you actually do know at least some basics, that really greases the wheels of that conversation and can get you the minimum data that you need to be able to function on their system, or get your students to have that data, to have that conversation. Make sense? Okay. So, stick to the basics. Okay? If you want to do an advanced networking class, Net Plus is a great target for that, because it gives them enough knowledge to really have that conversation effectively with IT without giving them so much that they're getting into the analytical topics of networking. Because again, networking goes super deep, but for those of you who know networking, everybody remember the OSI layers? Okay? How many times have you used that?
Every time I plug something in, I'm thinking of the physical. I just used it today.
But, fair
Yeah,
enough,
I know, they don't know. Well, the Net
Fair
Plus is, it's a real difference.
it
I
is.
think every school pretty much got to have it in here, so
Yeah,
it should be part of everybody's routine.
okay. It could be. So, but don't drown your students in information they don't need. Bob is an excellent example of this when he's teaching basic electricity. How much do you focus on Ohm's law, Watt's law, and those?
You know that, 20 minutes.
20 minutes. And the rest of the time is meters and how to actually do it, the practical end of it. Apply that to networking. Okay? I'm not saying that the knowledge is useless. It's very good knowledge to have. But 95% of the time or more, those basics are really what they need.
Is it a four-course set for the new certs now? Is that what it typically is? Because anybody teaching BAS, even just getting the Net Plus as the teacher, is probably, like Robert said, I think 95% of it you're never going to use or touch, but there's 5% that would make you really effective in routing.
It's a fact. And I would, on that certification side, if you have access to take classes for Net Plus certification or Cisco certified network associate or any of those, go with the Net Plus. That is, you're going to get the same information with far less proprietary information. Okay? Again, the CCNA classes, CCDA classes are really fantastic classes, but they dive deep and they dive into the proprietary end of how Cisco does things. Now, granted, about 90% of the time, your commercial network is running Cisco right now. They're the big kid on the block. They're like Microsoft. So having that information, not useless. I'm just arguing that the generalistic knowledge is more helpful. Okay? So, what's the purpose of a network? These bullet points are supposed to be hidden. Pretend like you can't read the rest of that. What's the purpose of a network? Communication between two or more things, right? Now, I don't know about you, but in all of my classes, when I'm talking about electricity or the refrigeration cycle or anything that, especially with new students or students that don't have a lot of experience, I use analogies, okay? There's always, everybody I'm sure in the room knows the water hose analogy for electricity, right? By the way, I hate that. I prefer using traffic, but hey, you use what works for you, right? Okay. Analogies for networks also really helpful because let's face it, IT is really complex, and especially for those of us who are growing a controls program out of an HVAC program or an electrical program, it's kind of intimidating, right? It's that big, scary IT thing, okay? And not all of our students are really, wanting to be the IT person, okay? So some analogies that I like to use for this: telephone systems. Everybody's got a phone, right? Everybody has an address that they can get mail to. TV and radio stations, that's a specific analogy that we'll get to. And two-way radios. All examples of networks. All examples of networks that most people are familiar with. So, what's required for a network to function? Well, we have to have some sort of media, right? We have to have some way to connect the devices. Traditionally, 15 years ago, we would have been talking almost exclusively about physical wired media connections. Okay? because the wireless connections were not common yet, though they were right on the verge, or they were exceptionally expensive. Corporate level connections, microwave antennas, things like that. Okay. Well, now we still use in building controls a lot of two-wire communication. Okay, occasionally four-wire. And in reality, you can bring that back to your students again with an analogy. Who has DSL or cable internet at home? Okay, guess what? Two-wire communication for the most part, unless you're one of those lucky places that has fiber. Okay, because coax cables for your cable TV, that's two wires. So two-wire communication may get a little bit downplayed because, you know, we always think in terms of these network cables that we've got plugged in all over the place. But really, you can put a lot of data through two wires, depending on how you do it. Ethernet connections are what we commonly think about for networks. The cable plugging our computer into the wall, our IP phone in our office into the wall, things like that. Bob?
Everything I don't know if you're doing research on it, but for the smart meters and stuff, we're talking about pushing it through your electrical lines.
Mm-hmm.
The signal now.
Yep.
So I don't know what kind of monopolization that'll do for the utility, but you know, we're actually talking that they might be able to use that. Or if they even have a cable up to your house.
Yes. It's a definite possibility. Peter.
For the benefit of the mic, when somebody says something really interesting,
Oh.
like Bob, you might want to
Repeat the
highlights
question.
so
Gotcha.
you capture.
So, to answer Bob's question about using the power lines coming into our house for communication purposes, they already are in a lot of areas for smart meters, and they're just injecting a communication signal on top of the electrical signal that's being passed, which is something that we have done in the electronic side for a long, long time. It's a little bit harder with AC than it is with DC because of the filtering required, but it's definitely possible. And I think I have not done specific research on the practicality of it. I know that transformers can become particularly challenging in that situation with crossing that data connection over. So where we're going to go with it, I don't know. But I think within our lifetimes, we're going to start thinking of internet less as a privilege or anything like that, and more as a strict utility, just like
I know
water
there's
and
a
power.
privacy issue, but any of that smart grid stuff, just because they're looking at sine waves and then you have when you start up. But I don't know. It'd almost be as trashy as Google. Taking information.
You're right.
Selling it to the wrong people.
Yeah. Anytime you're dealing with an ISP, a utility, anything like that, security of your personal data is a challenge. And that's exceptionally true in a lot of cases. Ethernet, fiber optics. Okay. Fiber optics are used throughout commercial buildings like this, and actually have been used in building control systems for decades as well. Our application in building control systems typically uses fiber optics as an extender for a network, because there's only a certain amount of distance you can go with a network cable, about 100 meters, typically. Two-wire communication can often go much, much further than that, but sometimes our systems still require that network connection. And extending that through fiber optics, which gives us what is effectively a near limitless length to our network, is an effective way to do that. And developing technology-wise, not so much for IT side networking, but still in development for building controls, is wireless technology. Okay?
You know the the difference between Ethernet and for bandwidth purposes? Is there like a data rating that they snap to it?
So is there a data rating for the different
Yeah, you have a
types?
piece of fiber versus just your standard piece of Ethernet cable, what bandwidth, there's gotta be some type of number that they
There
compare
is.
them to.
So right now, your standard Ethernet cable mostly maxes out somewhere around 1 gigabyte or gigabit per second in average usage. The theoretical limit is significantly higher than that, but you start having signal degradation issues very, very quickly.
That's with the 6-square twist.
That's
Separation.
part of where that helps, yes. Also separating your network cables physically from power cables and things like that. Fiber optics, because it is literally a light signal, is far less impacted by electromagnetic interference. And because, well, it's the speed of light, you can get huge amounts of data through fiber optics. I think the last one I saw for a common fiber optic cable is north of 10 times what Ethernet goes, both in practical and in theoretical limits. So I know that there are fiber optic cables running within this building rated for 50 gigabit. So that's 50 times what our standard network connections that we've got plugged in are. Jen?
When you're teaching about these, do you just focus on like the hands-on, terminations, which you've had us done with Ethernet, and then do you do fiber optic cable terminations? Because that's kind of difficult.
Yeah, yes. So as far as the practical application, teaching how to do punch downs and terminations on Ethernet, I think is very crucial for our students. Fiber optic, not so much. Especially in modern buildings, you really don't need that fiber optic extension nearly as often as we used to have to use it. Because most of the time anymore, we're riding on top of IT's network, and we're going to let them deal with the fiber side of it. Okay? I'm not saying, again, that it's useless, but there is one particular challenge with that. If you teach a student to terminate fiber and they get good at it, they're going to leave building controls like lightning because they can get paid way more to sit in a little air-conditioned truck and terminate fiber all day than they will ever get as a building controls technician.
An hour?
What's that?
What do they make in an hour?
Depends on where you are in the country.
Yeah, or what country,
Yeah, locally here, I think the last job posting I saw for somebody with experience was $150 an hour.
That's it, I'm out of here.
Okay. Now, granted, that doesn't take into account the spinal issues you're going to have from sitting and doing this all day. But for the high-end fiber terminations, that's real money.
My dad was in Iraq, he'd pay a guy 40 grand to show up, no matter what, it was a show up. He had houses all over the world, and he got like 10 grand for the week, but it was 40 grand just to show up, find the fiber optic.
Yep.
Just to give you an idea of speeds, fiber will run up to about 100 terabits.
So for the benefit of the mic, Robin just said that current fiber limits are pushing 100 terabits per second, which is an order of magnitude higher than I had previously said. So I'm a little bit behind. So, but those are our 4 primary network connections. Okay, we're going to get more into each of them, but right now, connection media is the important thing. We also need addresses, okay? And again, if we go back to our analogies of things like especially telephone and the U.S. Postal Service, we all have an address with the USPS, right? We all have a phone number that people can reach us at. Okay? That's part of that idea. So we have to have some sort of addressing scheme on every network. Well, not every network, but it's very helpful to have one. Okay? And if we don't, frequently that communication breaks down. So, the last thing we have to have is a common language, often referred to as a protocol. There are more protocols than there are strings of carpet in this floor. Okay? There are so many protocols that it's mind-boggling. We have institutions that's all they do is keep track of all the protocols out there. Okay? But if you think about protocols literally like language and conversation, if I'm speaking English and you understand English, we can communicate. But if I'm speaking Spanish and you don't speak Spanish, our communication breaks down. Okay? It's the same idea with a protocol. If I speak one protocol and you don't, we're going to be in trouble. So, media in building automation system networks. Okay? This is where we're going to start to diverge from how IT is going to talk about this. Because again, let's give our students a practical example of how they're going to use this information. Okay? Right now in our industry, there are two predominant options for physical connections for our systems. TwoWire Communication, things like RS-485, which we're going to hear some more about from Connie here later tomorrow, which is a two-wire communication. Okay? This is commonly what we use to connect, we'll call them simple control devices. Things like VAV controllers, smart thermostats, things like that, very frequently still use two-wire communication. Not exclusively. There are systems that are coming out that are 100% Ethernet based on their communications. But those are still limited in quantity. Okay? At the high-end controller level, we're going to talk Ethernet connections. This is your Category 5, Category 6, your RJ45 connectors. 8-pin plug, looks like a telephone connector except wider. Okay? That is where we are moving to. I think within the next 15 years, we will see that become by far the predominant connection for physical connections, even for very simple devices. Okay? Those are the kings right now. Okay? I did include ARCNET on there because there are still some companies that use ARCNET. It is a two-wire communication similar to RS-485, but just a different standard. Okay? You can't mix the two on the same network. But that
ARCNET's a coax. Just coax, right? Rather than just a single pair.
yeah, it's single pair communication.
What is a coax?
In our applications, the only company I know of left that's still using ARCNET is ALC. And it's faster than MS or RS-485 as far as communication rates go, but it is still using a two-wire shielded cable.
There's still some train trace for some instances out there that use ARCNET as well.
I thought we were talking about building control systems. No. Thank you, Lanny. I wasn't aware that Train was still using some of that. It doesn't really surprise me. And I throw shade at Train for it because, well, they're an easy target, quite frankly. But there is nothing wrong with ARCNET. It is a very fast two-wire communication standard. So it's very convenient. But it is something that we are seeing less and less of. Less common in our building automation system networks in current use are fiber optics and wireless. They both exist. You will run into them with some level of regularity. Like I said before, in relation to Jenny's question about teaching fiber terminations, we don't use it as much as we used to. It used to be that when you installed a building control system in a building, you ran your entire own network, okay? And that still exists to a certain extent, but more and more, we're offloading a lot of that work onto IT's network, okay? And when I say IT's network, I'm talking about the network that supports all of the non-building automation system devices within a building. They're already having to run all that wire. They're running all that backbone. They've put literally millions of dollars of equipment in many buildings. Why should we have to redo all of that work? Why can't we piggyback off of them, make our lives easier? Okay? So, fiber optics, again, not totally unheard of, just less common. Wireless. Okay? Wireless technologies exist within the building automation system sector. They're challenging in some ways. We historically used them as a single monitoring point solution. One of those systems where an architect designs a room that has all glass walls, and we need to put a thermostat in that room. So how do you do that? A wireless solution is one of the options. So you would literally have a battery-powered thermostat on the wall that would communicate at a certain radio frequency back to a receiver that you would wire to the input on your controller. Okay? More modern wireless solutions for building controls. Again, our friends at Train have a great system for this, where their systems run entirely wirelessly, or largely wirelessly. I think a lot of their thermostats are wireless to their VAV controllers, and their VAV controllers communicate wirelessly between themselves. Once we get into the more substantial controllers, plant controllers, controlling air handlers, chiller plants, boiler plants, they're more physically media required or reliant. The challenge with wireless networks within buildings is the building is one of the big challenges, because your wireless signal degrades anytime you have to pass through something, okay? Whether it's this whiteboard or the sheetrock wall behind it, or through a concrete ceiling, even through the drop tile ceilings or the people in the building. Anytime that wireless signal has to go through something, it degrades.
Especially all that rebar, I mean, that's a shield in itself.
Yeah, rebar especially, the ceiling grids, anytime you've got to go through metal, that becomes really problematic for wireless signals.
I think you're going to say the slew of kid students on the wireless apps out there.
That's actually where we come in with the next part. Traditionally, the way we build buildings and install building control systems is you build a new building and you install the control system. And guess who isn't there at that point in time? IT. Okay? So, building's done, control system is working beautifully because they literally have no competition for the airwaves. IT rolls in, sets up their building, and the number of buildings anymore that don't have wireless access points strewn everywhere is very, very limited. So, as soon as they start hanging their wireless access points, the airwaves start to get crowded, and unless you have really sharp people on both sides of that conversation, your building automation system loses. Okay?
If you can set up a mesh network that works on a specific frequency that allows your devices to communicate and exchange better information.
You're absolutely right, Lanny. You can set up a mesh network that works on specific frequencies that are not being actively used by IT. But again, that's that high-level conversation where you have to cooperate with each other. And that is one thing that has been lacking. I'm not going to say it's not on both sides, but it's really been lacking on the building automation side, okay? Because we don't know that that's a possibility. The traditional way that what happened when IT rolled in was suddenly your building control system goes funny on you. The building control guy comes back in, sees that he's got weak signals, turns up the volume on his speakers or his transmitters, and gets everything working again. IT gets a call a week later from the president saying, hey, I can't get wireless on my phone in my office. And IT comes in and goes, oh, yeah, you can't. What's this other competing signal? That's right. My dial goes to 11. And literally drowns out our signals. So if there isn't that cooperation there, building controls will always lose to IT. Our dial goes to 5, theirs goes to 11. Okay? Newer implementations of wireless are starting to realize what we did with the physical networks. Why not just jump on IT's wireless and use it as the backbone? Again, that takes some cooperation with IT, and there are very, very few manufacturers currently supporting that idea. But they're starting to come around to it. So give it another 5 or 10 years. Maybe we'll all be on wireless signals instead of wired Ethernet. I don't know. It's a possibility. Okay? Uncommon options. Cellular. Yep. There are actually systems that will use a cellular data connection, just like your security system on your home. Okay? The BAS View 3 actually has a module that it can run on for cellular applications. Contemporary Controls sells several different devices that will allow inter-site communication using cellular. Okay? They exist. They're typically applied as very spot solutions. Oftentimes when you have a client that refuses to let you onto their network, oftentimes that's where a cellular solution becomes a very helpful thing. Or if you have a site that's out in the middle of nowhere, again, it's an option. Okay? Coaxial networks. Coaxial networks do still exist. I mean, look at the cable internet industry. It exists, but we don't see it very often in IT anymore, or in building controls anymore. It used to be some of our earliest networks within buildings used coaxial wire. Thin Ethernet was a very common one. Almost doesn't exist anymore. So, really rare to see. And 4-wire communication within RS-485, RS-232, these serial type communications. We do occasionally still see some, but it's predominantly going to be on legacy systems. Okay? I think you are correct, yes. So instead of RS-485, it would be RS-422. I think you're right, Bob. Okay? But it works basically the same way.
They're making communicating thermostats like that, though.
Are they?
They're doing it out of 4-wire. When you look at the boards and you program them, their communication strategy is they change it around so you're looking at the wires a different way, but it looks like 422. So it's
Interesting.
existing in communicating stats in HVAC land. It's cheaper to make.
Yeah.
Some high-end model.
Right, like some of the high-end Lennox and Train models and stuff like that.
First train's going to do that.
Again, throwing Train under the bus. Gotta love it. Does all of this make sense? I know we kind of talked around the topic for a little bit longer maybe than we needed to, but again, understanding the basics, if you build the groundwork, you can only go up from there. Your basics are rickety. Whatever you build on, it's going to fall down. Addresses. This is specifically in RS-485 2-wire communication. Okay? Traditionally, this is one of the most common types of network with a building control system. It used to be that you would only have one network or IT network connection point on an entire control system in a building. Everything else was 2-wire or 4-wire communication, okay? And we still, as I said, use a lot of 2-wire communication, okay? BACnet, one of the predominant communication protocols here in the US, loves RS-485, or hates it, one or the other. Modbus, which Connie will be filling us in on, is another one that loves it, or utilizes it a lot, maybe is what I should say instead of loving. Okay. RS-485 only has physical addresses. Okay. Standard address range is between 0 and 128. And we can expand past that, but it's very uncommon to do so. As soon as you exceed 128 devices on a single RS-485 network, you're asking for trouble. It can be done if it's done properly, but everything has to be absolutely to the letter to get it to work reliably.
Have you ever done all the VRF stuff?
Mm-hmm.
That they keep pushing on everybody?
Yep.
They're gonna rip out a building in a couple years. That's all at 45 network. That's gonna be a night.
Yes.
And it's weird how they have addresses. Halfway.
Yeah,
Fourth address. Because that's where
because they're reserving it for some function. Yeah. From a practices standpoint, anytime you have an RS-485 network, the best practice is to have directly consecutive numbers. So you don't skip numbers where you can. Okay. Most systems, and I got to be really careful with using that word most, because anytime I do, the building controls industry is going to pop up and say, no, you're really wrong. But a lot of control systems that use 485, you can set your own addresses. You get to choose the addresses, okay? What is still one of the most common ways to do that is through physical dip switches. You typically have a block of 8 dip switches that you have to use a needle or the tip of a pen to set. Some of us need magnifying glasses to be able to read what those switches are. And it seems like every other company decides to go the opposite direction with their switches. Okay? It is very critical that when you are doing this, that you make sure that you do not have duplicate addresses on the same network. Otherwise, you're going to have problems. Okay? Another common method, not super common, but gaining in popularity or maybe losing in popularity, it's hard to say, is systems that will auto-negotiate their own addresses. So when you first power on a system to commission it, the first device on says, oh, I'm 0. This next device on says, oh, I'm 1. And if you get multiple devices that come up at the same time, they have a little bit of a conversation with each other and figure out, okay, I'm 1, you're 2, you're 3. Okay? Peter.
Why do you use the term physical addresses only?
So Peter's asking why physical addresses. And we're going to get to, I think, answer that question. So hold on to it, Peter. And if we haven't answered it here in a couple of slides, please ask it again. The one company I specifically know of that is still using auto negotiation for it is KMC Controls. They're kind of a mid-sized manufacturer. They were one of the early companies helping develop BACnet. So you can also, on some newer systems, you're starting to be able to manually set your addresses by software. So like the EasyIO controllers there in the back, It is part of the configuration that you get through when you connect your software to the controller. You can physically set those addresses. And most of the systems that have auto negotiation capabilities also have a way for you to override that and manually set it up once you get communication with those controllers established. The last option, which is probably historically more common than any of the others, is the address itself is embedded into the chip for communication. Echelon is an excellent example of this. Echelon or LAN, or Echelon is the company that made the LAN standard, which is going to come up here in a minute. But they're the only company that makes that communication chip, and each communication chip has a unique address. Okay? And that's how it negotiates that address. That is part of why we call it a physical address, because it is physically attached to the being of that device. The network card on your computer also has a physical address. We call it a MAC address. I think. There we go. Physical addresses on Ethernet-based systems. Okay. Before I go on, move off of this, Echelon is probably, or LAN is probably the most known system that uses that physical addressing capability, but by far it is not the only one. You will run into some companies that tie that physical address and match it to the serial number of a controller as well. That's a pretty common one. I think, didn't some of the old Johnson control systems do it that way? Yeah. Okay. Sorry, I keep bouncing back and forth between these two slides. Any questions on this? Kind of skimmed over it, and I know at least some of the people or most of the people in the room are already familiar with this. I just want to make sure we're all on the same footing. Robin.
Just a note for us geeks, that's 0 to 127, 128 to 255.
That's a very fair point. Thank you, Robin. You're absolutely right. My numbers are off by one on this. It should be 127 and 255. Thank you. Good catch. So, and the reason for that relates back to how we actually do these addresses, because these are conversions from binary. Information you probably didn't want to know. All right. Ethernet. Again, the RJ485 Cat5, Cat6 cable. Cat6E cable, I think, is the current modern standard in buildings. Okay? This is where we are commonly. It has a physical address. And in the early days of Ethernet-based communication, that's all we used was the physical address. And I should note on this slide, something missing is the physical address. What it is specifically called for Ethernet is the MAC address. M-A-C. No, I don't know what it stands for. We'll look it up. Okay? But it is a 16-digit hexadecimal number. Okay? When I say hexadecimal, does everybody know what that means?
10 plus 6.
10 plus 6. Our regular numbering system is decimal, 10 digits, 0 to the number 9. Hexadecimal adds 6 more on top of that. Letters A through F. Okay? I wish we could only blame that on IT, but it's all over the place. Your UPC code or tags are hexadecimal based. Okay? So that is the physical address. It is a useful piece of data if you're going to get deep into networking, because it is one of the ways that we use to initially establish network communication, and some deep down stuff as well. Now, that's our physical address. Now we're going to start talking about our virtual addresses, okay? And this is probably what we are more commonly familiar with when we're talking about network addresses. How many people have heard of an IP address? Okay, that's a virtual address. It is something that we set completely in software. There is no physical tie to the equipment itself, like the MAC address that's built into the chip of the network card. Okay. By the way, if you have a device that has multiple network cards, it will have multiple MAC addresses. It may or may not have multiple IP addresses. Depends on how it's being used. And yes, that is exactly the nightmare you would think it would be. Okay? We are still heavily based in what is called IP version 4. Okay? IP, by the way, stands for Internet Protocol. Okay? Version 4 is the addressing that has been around since 1970s or thereabouts. Okay? And is still widely used, even though there is IP version 6 available, and that's a whole conversation. Okay? But our IP version 4 addresses exist of 4 octets, is what they're called. Again, this is because they're based out of binary communication. We typically translate those to decimal numbers and separate each octet by a period. Okay? 192.168.92.68 is an example of an IP version 4 address. There is a lot of data built into this address that you can decode. Okay? Most of it, or some of it, is built into that first number. Whether we're a Class A network or a Class B network or a Class C network. And unless you get deep into networking, not a super useful information, okay, from a practicality standpoint with building controls. Because you're going to ask the IT guy, what's my IP address? And at the same time, you're going to ask for some additional information, like the subnet mask. Okay? The subnet mask that would match 192.168.92.68 is going to be 255. Give me a marker. .255. .255. .0. The guess is always whether somebody's going to say 0 or 255. Okay? This is a subnet mask. Sir?
And what if you want to limit your subnet size?
So, if you want to limit your subnet size, that's going to get deeper into networking than an initial class is going to want to talk about. That's going to get more on the designing a network stage, which I'm not, again, has usage, but not hugely useful for our average student. Okay, I think I hedged that bet well enough.
Yeah, I'm just curious what your take on that was. My advanced instrumentation and communications class, we get into subnet sizing.
So, developing different subnets has an exceptionally useful practice, especially when you are trying to organize the network on things like a multi-floor building or a multi-building campus, or trying to segregate differences between your IP phones versus your IP security cameras versus your desktop computers. There are definite uses of it, but just like most things, it adds complication. Okay? But yes, it is an exceptionally useful thing. It is a very common practice. And if you get into designing networks, it is something you do have to talk about. Okay. The other thing that you're going to talk to your IT people about is a default gateway. Okay? Because networks are really, really useful within a building. Okay? But what happens the first time you need to communicate outside of that building? You have to know how to get out of the building, right? For us, we know we can go out the door, right? Or in an emergency, there are some windows back there, right? We can get out of the building. This computer, unless we tell it how to get out of the building, is just going to run around in circles inside the building. Okay? That default gateway is the address that your computer can talk to get out of the building. So if you need to get to Google, unless you're at Google's data center, you got to get out of the building, right? And even Google has to get out of the data center most of the time. So, okay. Default gateway, yeah, we'll get into a little bit deeper on what that is. Typically speaking, it is going to look a lot like your network address that you've been given. Okay? Not always. Depends on the size of your network. But in a lot of instances, it's going to look very similar. So maybe it's going to have the first 3 octets match and just change this last number. Or maybe it'll have the first 2 octets match and change the second 2 numbers. What's that?
0.1.
0.1 is a common one for common default gateway for a lot of consumer grade equipment, yes. Sound good? Totally lost and confused yet? Dang, I'm not doing my job. All right. Network architecture. I had to bring this one in because it is an important conversation to have about the devices that we use and how it ends up looking if you were to draw out the network. Okay? Modern networks within a building are a very flat structure. Okay? At the top of that structure, typically one in a building, is a router. Okay? How many people have a router at home? Okay? For most people, this is provided by your internet service provider, and it's what communicates or establishes the network within your home and communicates back to them at their distribution hub. Okay? It is not entirely dissimilar within a commercial building. It's just in most commercial buildings, the building owner has to pay for that router. Okay? And most of the time, that router is an exceptionally expensive piece of equipment. They're very intelligent, very capable, and accordingly very expensive. Routers serve the very specific function of allowing us to communicate between different networks. Okay? These are referred to sometimes as gateways. And there is actually a difference in the networking world between a router and a gateway. They are different devices, but for our conversations, they're effectively work the same. Okay? So, routers can also be used within a network, like a building controls network, to communicate, change communication types between an Ethernet-based network and an RS-485 network. That is a very common router that we use in building controls. Matter of fact, there is one sitting on the back table right behind Russell. Okay? Contemporary Controls, one of their star products, or several of their star products, fall into that exact category. Okay? Next step down from our router is switches. Okay? Switches are very common within a building. Most buildings, well, depending on the size of the building, you will have one or more switches. And this is really where our architecture flattens out. If we were to draw it out, we have our router at the top. By the way, I should probably warn you at this juncture in time, I can't spell. So if I write something on the board and the spelling looks wrong, it's probably because it's wrong. Okay? But we have our router that lets us communicate to and from the outside world. Underneath the router, or yeah, we'll call it underneath, we typically have a series of switches.
I got away from that router.
What's that?
I got away from the switches.
Yeah, you're using hubs?
All routers.
All routers?
All routers on purpose to get them to do what they want.
Interesting.
I have to show you.
Yeah, I'm really curious about that. Okay.
But that makes it more pyramidal or flat. Right.
Okay.
Yeah, just because, I don't know, it helps them understand it better.
Yeah.
Okay, listen, I was on the switch thing, I'm like, damn, I just paid so much money for no reason.
Curious how that's going to work. We'll talk later. Your main switches in a big commercial building like this are going to be connected to the router via fiber optic cabling. Okay? Sometimes in older buildings, we actually had a dedicated fiber optic switch. So each of these switches and the router would connect up into a higher level switch. Most often in current buildings, it's more of a daisy chain type effect. Okay? Where they have an in and an out port basically built into each switch. Okay? Saves on cost. Below these switches are all of your end devices. So you're going to have your IP phones, your desktop computers, your security cameras, your building automation systems, whatever all you have hanging onto the side of your network, your wireless access points. That's where it's all going to live. So in a lot of modern networks, you really only have about 3 tiers. Okay? That's how we get the very flat architecture. Network switches can be as small as 5 ports, like the ones that we have on our desks, and upwards, I think 48 is the biggest I've been seeing recently. After that, it gets a little bit impractical from the power supply standpoint. So, buildings like this, we have, what do we have? I think we have 8 switches for this building. Of course, every TV, every desktop, every phone has its own connection. So, every given classroom has about 10 connections in it at least for us, so we're kind of heavy on that. And that's really not that uncommon for a modern building anymore. So, okay. Making sense?
What have you seen with power over IP? Because a lot of the camera boys got out there with the power.
Mm-hmm.
It's real easy to induce a magnetic field and fry them off.
So one of the, I can't really even call it a recent development from the IT standpoint, is what's referred to as power over Ethernet. Okay? If you have an IP phone on your desk in your office, it's power over Ethernet. It doesn't have a separate power supply. Okay? What they're doing is they're using 2 of the wires that are built into the Ethernet cable to literally send a DC power signal to the device that's plugged in. Okay? IP phones were one of the first ones that came along, and shortly thereafter, the security folks, as Bob pointed out, came along with power over Ethernet powered cameras. Okay? And yes, it is a huge thing that's going on. I think it is only a matter of time before our building controllers start getting power over Ethernet as well. I think that is the development of the new power over Ethernet standards. If they get it to the point where they can provide enough power to our controllers to power the controller and a couple of actuators, like a damper actuator and a valve actuator, once we get to that point of the power standard, that is when we're going to change over, I think, completely from RS-485 networks within a building to Ethernet networks. Because that's the point at which you then are only pulling one cable between your devices. So
And it's just the distance, though. They can't compete with distance.
distance is a challenge with that.
Size of the wire.
Yeah,
And the price.
yeah. Because as soon as you start telling IT, hey, I got 80 VAV boxes on this floor, I'm going to need 80 Ethernet ports, their heads kind of explode. So once we get over that hurdle, that will be there. The question is whether we're going to get there first or reliably jump on from the wireless standpoint. And then we're just pulling power wire. It's a race. Who's going to win that one?
Yeah.
I don't know. But yeah, power over Ethernet is a good conversation topic, especially if you're talking about security cameras as part of your system. It's a good point, Bob. All right. Also, on a network within a building, you have some server functions, okay, that are really pretty requisite for the functionality of the network from a practical standpoint. Please note I said server functions, not servers. A server is a physical computer or a virtual computer, if you really want to get froggy with it,
I think
that
people
does things.
created this mess
They do.
with clients and servers. Their communication's all upside down.
Yeah. But server functions are very specific tasks. In small and even some medium-sized commercial buildings, those server functions are built into our router up here. And those two specific functions are DHCP and DNS. Okay? Now remember we talked about our virtual addresses, right, for Ethernet? How would you like to have to go around and program that address into every device on a network? Remembering, in this building we've got 60 rooms, 10 devices per room. Challenging, right? Keeping track of it. So we developed a system that would automatically hand those out to every device. Okay? And that is what we call our dynamic host control protocol. If you think about it like City Hall or the planning department assigning addresses to new properties as they get built in a subdivision, kind of works as an analogy. Okay? The other one is the domain name system. Okay? This is think about it like a database that keeps track of information about the network itself. Okay? Unless you want to get deep into networking, that's probably about where you want to stop with both of these because they can get complex.
The client-server talk, that has to go on, because it's confusing as hell. You know?
Yes, and we'll get to that.
Yeah.
I don't talk about that until we get into BACnet, because that's a point at which you can more effectively have that conversation with an example. Because you're right, the client-server conversation can be very confusing. Okay. All right. Sir.
Well, managed switch.
Managed switches versus unmanaged switches. That's IT person territory, and we let IT handle that. Unless you are installing so much equipment that you are installing your own switches, okay? For the purposes of this conversation, though, knowing the difference is good. An unmanaged switch is one that you plug in and it has very little brains, okay? It still has some brains, but it handles all of its own self automatically, okay? Most switches that are going to go into a small commercial building are unmanaged switches, okay? You start getting into medium commercial buildings or commercial buildings that are managed by an actual IT department, you're much more likely to run into managed switches, which have some significantly higher level functionality. Not the level of a router, but definitely way more brains than like the unmanaged switches that we have on our desk. Okay. Effectively answer that question?
Basically. But
Basically.
do you think in the future we'll get into the level of needing a managed switch in the HVAC to go with an Ethernet network?
So this is an opinion, but it does bring up a really important topic from a security standpoint. Okay. Who remembers the Target hack where they lost, millions of credit card numbers and data? What was it, 5 years ago, 6 years ago, something like that? So say that again, Mike.
Through the EMS system.
Through the EMS system, the energy management system, or the building automation system. That is what the headlines read.
Russians.
So, there's an interesting sidebar about that. You know why Russian hackers are so good?
We help.
No. It's because back in the Soviet era, what would happen is the Russians would buy like one of something we had and pass it to their engineers to deconstruct and build their own version of it. And they did that with computers. But they were some of the worst, hardest to use computers on the planet. So as soon as somebody learned to use that computer, it became very easy to use other computers. So they built this huge level of skill because they had garbage to work with.
That sounds like Russian history.
Yeah, right? So, but what everybody remembers about the Target hack is it was through the building automation system. And that's what the headlines were for weeks after that. And it was total garbage. What actually happened was one of their HVAC and building management contractors opened a spam email and got a keylogger on his computer. And he was logging in to send Target a bill, okay, for his services, for his company's services, and that password and username got logged and sent to a hacker. That hacker then used that password and username to get into Target's system, okay? And I want you to imagine when you walk into an average commercial building, right? You're walking into a hallway with a lot of different doors, right? Okay? That's how most modern networks are set up. They are segregated, so when you walk in the door, you have to pick which part of the network you're getting into. Okay? Well, Target didn't have their stuff set up that way. And as soon as he walked in, it was like walking into a warehouse with everything going on all at once. And so, because of that lack of segregation of their network, that was how they were able to gain access to the point of sale system. That's how they got Yep. It was a failing of IT to secure their own network.
GE, my dad worked on their network, and GE was the same way, where one keystroke could have deleted everything.
Yep. When I first started working as a contractor for the college, the Culinary Arts Building, which is, you know, about a quarter of a mile that way, was being built. And when we hung our supervisory controller in that building, it kept shutting down randomly. Like it would just stop talking on the network. It would still log its data, and if you reset it, it'd come back up, hey, what's going on? But we looked at it and found that it was literally shutting off its network port to protect itself from all of the traffic it was seeing. Because the college's network at that time was, again, that big warehouse. So, how does this relate to managed switches? One of the most useful things that you can do with a managed switch is create virtual networks, to create those rooms off of that main hallway. So you can have a room specifically for your point of sale system. You can have a room specifically for your security cameras. You can have a room for your IP phones. You can have a room for your building automation system. Okay? That, I think, honestly, is the modern standard within IT networks. If you run into a building that considers itself to be modern, but hasn't done that with their network, you need to fire the IT department. VLANs is exactly how they're referred to, virtual local area networks.
So you can hack into the managed switch software,
Well, yes.
and then everything goes.
There's a weak point in every system.
Reorganize the rooms.
Right. And dealing with those virtual networks, when IT decides to rearrange things within their own house, can be challenging for our students, especially for those who get onto the service side, because IT typically unilaterally decides we're going to do this. And sometimes the documentation of what exactly was on a given VLAN disappears in the process. And so suddenly they will have reorganized, say, this building, and now we can't see the IP cameras, the secure door card access, or the building controls. We have no idea why. We didn't do anything. We just changed everything about the network. No, it's not our fault. It's your fault. No, I haven't had that conversation. Why do you ask? Lan?
So I want to change the conversation a little bit to something that you talked about with the DHCP.
Yes.
And I'm curious, your point of view or anybody else's, because you talked about, taking the addresses and physically programming thing instead of using DHCP, which is something that we actually do, and we spend
Yes.
a bit of time on it because we want those MAC addresses to be programmed, because we want to reserve a specific section of addresses that we want to be ours and ours only within the school that we're using the systems. So, power failure or whatever else,
Yep.
addresses won't be lost to anybody else. So I'm just curious how much time is being spent by anyone, to talk about that action.
So that's actually a really significant conversation. I don't think that it is being given enough time at this juncture within the companies and standards bodies that are dealing with building control systems. And that conversation really is dynamic addressing versus static addressing. Okay? Dynamic is what happens with our dynamic host control protocol. The server function decides what the address is going to be of this computer and this computer and that computer. When we physically override that, or if that is completely lacking within a system, and we have to type in that address ourselves, that is what's referred to as a static address. Okay? And that is predominantly what is used in building control systems and like our IP security cameras. Because, again, as Lanny stated, when you lose power, if your DHCP server function goes a little bit haywire, it may decide that what used to be .2 is now .28. And most of our systems rely very heavily on that virtual address. And that is really exceptionally challenging. It really almost requires us to use static IP addressing.
Just go back to the first one, YT. Plug it, start over.
Absolutely right.
I think for the general person, you know, the layman who doesn't know anything, DHCP is wonderful. Personally, I hate it. Yeah, I mean,
Yeah.
I think it's a horrible thing, and well, maybe because I'm a control freak, I just want to know
Yeah.
what's going on there, you know. So,
Absolutely. Now, there is provisions within DHCP to block out addresses or specifically always assign the same address back to the same device. And that uses that physical MAC address. So it's literally mapped one-to-one. So this MAC address always gets this IP address.
and that's what we do. We use the MAC address.
Yeah.
We don't assign static. We join the MAC address.
And it works great until one of two things happen. The DHCP database gets corrupted by a power surge or somebody hitting the wrong key, or IT decides to reorganize their network and forgets, you know, loses the documentation of why did we have these statically assigned over here. So, does it happen frequently within a given building? Depends on your IT department. I've run into some departments that as the minute the head of the networking department changes, they decide to reorganize the entire system, and it's every time.
Administration.
Yeah, it's like stomping out your territory. I'm not going to do it the same way the last guy did, even though really it's the exact same way. I'm just using different numbers. And sometimes there's valid reasons for it because your network grew significantly. Sometimes there are less valid reasons. So I think as our whole networking picture expands, I think we're going to have to rely less on static addressing and more on dynamic addressing, just because of the nature of the addresses we're using. The solution for that is this DNS, domain name system. Because what that then does is, instead of relying heavily on that address, starts using the name of the device. In building controls, most of our systems really aren't to that level yet. They should be, but I'll tell you, building control systems, 10 years behind IT.
50, yeah, 30.
Sometimes, when you count in the fact that most control systems are installed in a building and last a lifespan of about 20 years, that totals up to 30. So, and the reason I think we're going to go more towards dynamic hosting is because, remember, back one slide to our addressing, remember this IP version 4? Well, IP version 6 exists. IP version 6 uses 6 hexadecimal addressing blocks. There are more IP version 6 addresses available than there are grains of sand on this planet.
They don't want to make the secondary statement, right?
What's that?
They don't want to run out again, right?
And that's exactly why IP version 6 exists, is because we were literally running out of IP addresses. In theory, IP version 6 has enough addresses so that literally every device will have a unique IP address.
I used an example in my class that if you were to put an IPv4 address spaced equally over the surface of the earth, you could walk around pretty easily without stepping on one. But if you did it with IPv6, you would step on more than one with every step.
I think that's a great example. That is a good one.
And if you recall, Bill Gates was asked one time, why did you set the 256K limit for RAM and DAWs. He said, who would ever use more than that?
Well, to follow that up, I mean, lighting control is another area that each individual lighting source has its own MAC, MAC address.
Absolutely right.
When you think of that, just like in this room, how many you have throughout the whole building, I mean, it makes HVAC look small.
It really does. It really does. Depending on how it's set up. If,
Boy, I tell you, when those MAC addresses get low, it's one heck of a building to try to straighten out.
I
When,
don't doubt it.
all your control devices, light switches and all that are all the control devices. And now they can control any which way lights are supposed to be controlled.
Yeah.
And it's,
You must just all call the building for a year till you figure that out.
Yeah. When any of our control systems go haywire, things start to be problematic, but there is none, the two that you will find out went wrong first are card access, because nobody can get into the building, and lighting control, because nobody can see once they get into the building.
resiliency, I mean, that's gonna be that's a huge one.
Yeah.
Resilient, I mean, lighting controller, if you lose a lighting controller, and there's no bypass, the whole building's down there, that, multiple times where it goes. All this networking, it's like, it's Ray Bradbury, there will come a soft ring, and all the control in the world, one little drip of water.
It's true. All right. I think we went a little bit off topic, but it was really good conversations. And they are conversations that you should expect to get from some of your students. Because let's face it, even though most of us are teaching out of kind of more the trades perspective, the people that we get coming in come from everywhere, and some of them know way more about given topics than we do. Okay? All right. Protocols. I should go back. Does anybody have any questions on physical media or addresses past what we've already talked about? Okay. Protocols. The languages that are spoken on a network. Some that you have probably heard of and I guarantee interacted with. HTTP, not just the beginning of a web address. That stands for Hypertext Transfer Protocol. It is the language of web pages, okay? And it talks on what are specific ports, okay? This is the first time we've talked about ports. If you think about ports kind of like radio stations, that usually helps. So you know if you want to listen to country music, you turn to 90.3, right? You want to listen to R&B, 100.7, okay? If you want to listen for web pages, you're going to be on port 80 or port 443. A lot of times you are going to start running into multiple ports for a single function as we have transitioned from insecure communication protocols to what we are currently terming secure protocols, okay? So like when you log into your bank, when you go to that first web page, chances are you talk to it on port 80 to establish that conversation. But as soon as you start logging in, it's going to transfer you over to the secure section so that your passwords and username are encrypted while they're being transmitted. Okay? You're going to get more and more of that as we move forward. Okay? SMTP, Simple Mail Transfer Protocol. How many people have read or answered an email today? You used it. Okay? There are technically 4 ports listed for SMTP, but only 2 of them are official anymore. TCP/IP. Okay? Transmission Control Protocol and Internet Protocol. This is the basis, this is the groundwork for most of what we deal with on a network today. Okay? This is the basic, this is the spoken idea of spoken language before language existed, kind of level of protocol. It's what we build most things on past that. And you will notice this does not have a port number because this is below that layer. This thinks, this is what came up with the idea of the ports. When you are talking on port 80, you're using TCP/IP to use HTTP. Okay? It's the concrete that the rest of the network is built on the protocol side. Okay? And it is a connection oriented. Okay? And when I say connection oriented, think talking to someone on a phone call. Okay? I know Bob's number. I call Bob. I'm talking to Bob. Bob is talking to me. Okay? That is in comparison to UDP, the user datagram protocol, which lives on top of TCP, kind of, and uses port 67. This is a connectionless or a broadcast type protocol. Okay? So I am talking to everybody in this room, right? I am talking to that wall. I am talking to Larry, who's not listening to me because he's got headphones on. Okay? This is a broadcast signal. Anybody who walks in, who exists within the range of it, can listen to it. Okay? That is UDP. Okay? So you can imagine on a network how ugly it could get if everybody used UDP, right? Think about how loud this room gets when we hit break time and we start splitting off into our own conversations. Sorry, I'm trying to watch the time because I've got to get our lunch presenter on here in a minute. Okay? Make sense? Okay? We heavily use both of these. Well, not heavily. We want to use TCP as much as we can. We use UDP when we have to. UDP is technically a faster communication protocol. You've had great questions so far. Don't disappoint me now.
It'd be interesting to give some network examples of UDP. I think that'd be good for people to hear more. I love the radio station. That's a great way to look at it.
Thank you. We'll get to specific examples of those because anytime I do the initial conversation on networking, I'm not just talking about networking. At that point, I change over. Like right now, the next thing we're going to talk about is BACnet and building automation system protocols.
Isolation of UDP too.
Yeah, and we will use that to frame the conversation to get further examples.
Can you turn the slide back for a quick second, please?
Sure.
Thank you.
Not at all. Other questions?
Many ports are,
How many ports are there? I don't know.
where are they physically at?
What do you mean, where are they physically at?
People on the internet, where are they? Servers?
They are... That's a tough question to frame an answer for because there are no physical ports. There really aren't virtual ports. It's more of kind of an agreement that, you know, this, it's a tag that is built into every communication that we do. We include that data on the port or of the port. So if you were to address a letter to someone, one of the things that you include is their zip code.
That's what you were saying, the radio station.
Right.
It's like the,
It is.
I think it's more like a virtual channel.
A virtual channel would be a great way to phrase it as well.
Yeah, we're lot of gaming on Xbox, set up ports on your routers, so you don't have any, you try to limit the amount of, lag that you get in any system. So Xbox Live has its own port
Yeah.
that it wants you to have on there, just like everything else. So when you're shooting at someone, don't shoot at it. Like, if
You
you're
want to
actually
use the right port, is that what you're saying?
Yeah.
So, did that help, Romero? There is a group that does track those. I would have to look it up, but it is a website you can show people. We'll hit that after lunch, just as a quick bring it up, because I did forget to include that presentation.
Technically, there's 64K ports.
64,000 ports. Okay.
65, 556.
The number is actually 65535.
Yeah.
Fair enough. And that,
You get there.
yeah,
You make that 94.
yeah, yes. So, other questions?